the last type of t-test we can have. So we have Jen here measures the masses in kilograms of a random sample of miniature ponies from 2 different sellers with the following results. So in this one, they're giving us a list of data points. And they want to know, is there evidence that the 2 sellers have different mean masses? So in this case, we are still going to go to statistics, except for now I have information to put into my list. So in list 1, we're going to put seller A. So we have 6.2, 5.1, 8.7, 12.1, 18.3, and 5.4. In list 2, we're going to put those of seller B. So you will notice that these do not have the same amount of data sets in both seller A and seller B. That is perfectly okay. It will still be able to do the t-test. So you're just going to put in all the data, even though the columns are not going to be equal. So once we have our data in there, we want to perform a test, t-test. We have 2 samples, seller A and seller B. We want 2 samples. This time our data is coming from a list. So we have a list of information, so you can see it changes what it wants us to know. Again, here you're going to put your alternative hypothesis. And this one, we want to know if their mean masses are different. So I don't care if one's bigger or smaller than the other, I just want them to be different. So list 1, seller A, I put in list 1. Seller B, I put in list 2. I don't have any frequency sets because everything just shows up once, so those are going to stay 1. Make sure pooled is on, and we just hit execute. So our t-test is 0.673 with rounding, and our p-value is 0.514 with rounding. So this p-value is greater than our significance level at 5%. So we are going to not be able to reject the null hypothesis. So there is not statistically significant evidence that these 2 sellers have different masses in their miniature ponies.